Performance monitoring. In this nugget, we're going to talk about monitoring the performance of various aspects of your system. The idea is that if we keep track of the way the system is performing on a day-to-day basis, then we'll be able to pinpoint which aspect of the system is responsible when we see performance degrade. Let's get to work. Well, let's start by talking about the aspects of the system of which we want to monitor the performance of. Okay, so there's the memory system, the disk subsystem, network traffic, and the CPU. Okay, so these are the four major components of a system, and this is what we're going to want to keep track of to determine how the performance for the system, or what the current state is of the performance of the system. Okay, so now the question is, what do we actually monitor relating to those four pieces of the system? Well, we want to monitor the overall performance of the system. Okay, now this is kind of a nebulous concept. We'll talk about what this means when we go out to the Linux screen and start looking at some stuff. But basically what this is kind of like the load average, and you'll see there's some statistics and some commands that we can look at that will give us an idea of the overall performance of the system. Okay, we want to look at the processes that are active on the system. A lot of times if there's a performance degradation, then there's some process consuming an inordinate amount of resources. Either the process is out of control or the process is functioning correctly, but it is just a very intensive process. Okay, so we want to monitor the active processes on the system to determine where that performance problem is coming from. We want to look at the memory usage of the system. A process that is going out of control might be consuming a lot of memory, and that would cause other processes on the system to not perform as well. Disk usage and performance. Again, disk usage, if the disk is filling up, for instance, then there's less free space on the disk. Maybe that's causing things to be written in pieces around the disk, and so then disk writes and disk reads and things like that are going to be slow because it's not coming in like large chunks. It's spread out all over the disk, and that's harder to read and write files to the disk when it's all fragmented like that. Okay, and so that affects the performance of the disk, like you know, the I/O, the bandwidth of the disk, how much data is coming back and forth from the CPU to the disk. And then we want to look at CPU utilization. Okay, so how much CPU cycles, how many of these CPU cycles are being used, which processes are using them, how many are still idle, that sort of stuff. And then network usage. We want to determine if the network is the cause of the performance slowdown, so we'll have to look at how much traffic is going over the network, that sort of thing. Okay, so the big picture here is, how do we diagnose these performance problems? And I've given you a few questions here that you can ask. Well, the first question is, what is the overall system status? Okay, does it seem like the system's loaded up? Is there some noticeable performance lag when you do certain tasks? Okay, you know, that's the first question that you need to ask. Then you need to narrow down the subsystem that's responsible for the poor performance. Like the first slide there, we said what the four systems were: the memory, the disk subsystem, the network traffic, or the CPU. We want to narrow down and say which one of these is the cause for the poor performance. Okay, then the final question is the poor performance affecting the functionality of the system? Is this some temporary thing that's happening that you can completely explain that you don't expect to happen again? Or is it something that happens regularly, but it really doesn't affect the functionality of the system? Okay, so you have to lay this, you have to make, put all this in context. Okay, and if the poor performance is not affecting the functionality, then you're not really, under the gun in some sense. Okay, but if the poor performance is affecting functionality, then you are under the gun to try to fix the system in such a way, or remedy the problem in such a way that everyone else can have functionality of the system. If you end up killing a process or stopping some job or something like that is causing the poor performance, and it's causing everyone else to lose functionality of the system, then it's more important usually to have all those other people have functionality and then have this one thing sort of not working anymore, and then remedy that situation offline. Okay, so there's like a general idea of performance monitoring. Now we're going to move out to the Linux screen and look at tools that we can use to monitor all of these various things that we were talking about on the second slide there, all these different aspects of the system that we want to monitor. We're going to go out to the Linux screen and look at tools that we can use to do this monitoring. Well, let's start with sort of the most basic system performance monitoring tool that's out there, and that's the uptime command. So if I run uptime, then I see a few things. One is I see how long the system has been up since the last reboot, but what I'm really looking at here is this load average field over here on the right. Okay, so you can see here that the load average has three numbers: 3.20, 3.08, and 2.55. Okay, what these three numbers represent: the first one represents the load average in the last 1 minute. This represents the load average in the last 5 minutes, and this represents the load average in the last 15 minutes. So just by looking at these numbers, what's happening to the load on the system? Is it increasing? Is it decreasing? Has it peaked and now it's going back down? Well, it looks like it's increasing steadily. Okay, in the last 15 minutes, the 15-minute window, the load average was 2.5 roughly. In the last 5 minutes, it was roughly like 3, and now it's up to like 3.2. Okay, so the load is steadily increasing. But what do these numbers mean? Well, these numbers, they don't have units or anything, right? So this is what I was talking about before with overall system performance is kind of a nebulous concept. This load average is a nebulous concept. There's no units attached to these things. It's not a very quantitative measure, okay? The only way you can understand what these numbers mean is by constantly monitoring your system to see what the typical load averages that you see on your system are. And then when you go to look at this, if you know that your system hasn't been up over 3.0 all year, then you'll know that this is a heavily loaded system right now. Okay, and now whether the performance is degrading or not, that's another issue, right? If the performance starts degrading, if the performance is degrading right now and you haven't seen a load over 3.0 all year, then this is telling you, okay, you know, it's verifying the fact that your performance is suffering because of the load on your system. Now, where is this coming from? Why is this happening? This is all stuff that we still have to determine. This is just a general, you know, like a pulse of your system, and this is telling you that something's up. Okay, but you know, these numbers, like I said, and let me just stress this, that these numbers alone do not mean anything. One particular system could easily handle a load average of 3.2, while some other system might be suffering when it's at a load average of 3.2. It depends on, you know, the processor, depends on the brand of processor, the speed of processor. All these things will affect what kinds of load average the particular processor can handle. Okay, so that being said, you know, like I said, you just have to keep track of this. Either look at it regularly, write a little script that pulls these numbers out, and then you know, writes them to a file, and then averages them all up at the end of the day, and you know, do that for a month or something, and then you'll see what a typical load average is on your system. Okay, so that's the uptime command. Now let's look at the top command. Well, we ran the top command back in the introductory videos. I just want to run it again right here real quick, just to refresh your memory as to what it was. Okay, top is this program that updates the screen sort of dynamically here based on the most current information about how much processes, how many resources processes on the system are consuming. Okay, so let's just look at the various columns in this chart. Okay, so the leftmost column here is the process identification number. The next column is the user or the owner of that particular process. If we jump out here, this is the percentage of CPU time that the processes are using, and this is the percentage of the memory, the RAM in our system that the processes are using. And then the command over here is the actual command that's being run by that process. Okay, so what we can learn from this is what processes on the system are consuming the most CPU time, the most memory, that sort of stuff. And if you can see here, if you watch this, you know, here's this process by Annie. It's consuming 8.7% of the CPU, okay, and now it's jumped down to line 2 because some other process is consuming more. Now that process by Annie is consuming 8.9% of the CPU, and again, when it updates, it's down to 8.7. There's this process by Charles consuming 1.3% of the CPU, and now you can see it jumped up to 7.3. Okay, so it's this dynamic updating, right? And it's just like the most, like I said, the most current sort of snapshot of the system, right? Because inside the processor, these processes are, you know, being exchanged in and out of the actual CPU hundreds of times a second, if not more. Okay, and so you know, they're not getting large slices of the CPU at any one chunk, but this is just reflecting like the overall interval over the last 2 seconds, what percentage of the CPU time was used by that particular process. Okay, and if you want a more detailed discussion of the top command, go back to the introductory videos because we talked about all the various fields in here. We talked about all these numbers up here and what they mean. We talked about different options that you can use with the top command, or you can go through the info pages carefully and you can learn all that stuff there as well. Okay, so that's the top command. I'm just going to quit out of here with a Q, and then I'm going to show you another system monitoring tool that's like a graphical based system monitoring tool, and this is called the GNOME System Monitor. Okay, so here there's different tabs here. Process listing, you can see all the different processes, or you can get a graphical representation of how much CPU usage on the system, what's the memory usage, what's the swap space usage, that sort of thing. Okay, or you can go under process listing and then you can view different processes. So you can either view all the processes on the system, my processes, and since I open this window as root, they would be the processes owned by root, or I could go to active processes. I'm going to go there and see what's active on the system right now. And you can see kind of the same processes that were showing up at the top of the top screen. The processes by Annie and Charles. You can see the root process that's actually running the system monitor is consuming quite a bit of the CPU time. Okay, so this is telling us, again, a very quick sort of snapshot of the system, what's going on. Some people like, these graphs to give them an idea if these things are peaking up and down. It gives them a pictorial representation of what's going on the system. Okay, so this is just another tool that you can use to monitor activity on the system. Always be careful when you're monitoring activity on the system that you, by monitoring it, are not, putting a burden on the CPU. Okay, and you can see this GNOME System Monitor, like I said, is consuming quite a bit of memory, like 9 megabytes of memory. It's consuming, like 10% of the CPU time. So it's not really impacting the performance of the system. If the system was really loaded up, though, okay, just completely loaded up, and then I add some monitoring to it, then it's just going to, cause more problems. Okay, so you have to be careful when you monitor the system that you're not actually impacting the performance yourself by monitoring it. All right, so the way that you get into this system monitor is you just type gnome-system-monitor at the command line and you can get in there. Now we're going to go ahead and look at another command called free. The free command displays memory usage on the system. Okay, so the first line here, we're talking about physical memory. All right, so here's the total amount of RAM in our system, and then this is the amount of RAM that's being used, and this is the amount that's free. Now notice that these two numbers, when you add them together, add up to this number over here on the left. Okay, so it's telling you, exactly how much of the memory is being used, and you can see right now a large percentage of our memory is being used because I've got some processes running out here just to consume memory, so that this discussion on performance monitoring is more interesting. Okay, now the next line down here has to do with how much memory is being used by the system, okay, by system buffers and things like that. Okay, and again, these two numbers here add up to this total up here, 255,408. So this is telling us that 72,000 some odd kilobytes out of 245,000 kilobytes are being used by system processes, okay, instead of user processes. All right, so if you want to determine how much memory the users are using up, then you have to subtract this 72,000 from the 245,000, and you'll get even more information from this particular screen. Okay, now the last line here has to do with swap space. Okay, so this is telling us how much swap space we have on our system, and how much of that's being used, and then how much of that is free. Okay, and again, all of these numbers are in kilobytes. Okay, so so this is telling us what's going on in the system in terms of memory usage. Now the problem with free is that it's just kind of like a snapshot, right? That if we want to see, how it's progressing, the best way to do this is to use the watch command. Okay, so I can say watch free. All right, and then what's going to happen is that this screen now becomes sort of dynamic, just like the top screen was dynamic. It's changing numbers on the screen, every 5 seconds or so, and those numbers are reflecting the current up-to-date memory usage right now. Okay, now it's a little hard to read this because the numbers change and I don't know exactly what they used to be or what, things like that, or which ones change. I see a little flash on the screen. So let me just hit Q here to quit out of this, or Control C to quit out of this. And now what I'm going to say is I'm going to say watch, okay, minus N1. That's going to change the interval down to 1 second. I'm going to say minus D, and then I'm going to say free. The minus D command will help delimit or highlight the ones that are changing. Okay, so I'm going to do this now like this, and now when something changes, you can see how it gets highlighted, and now the changes are happening every 1 second. The screen's being updated, so now we can watch and see how things are being changed. Okay, and they're basically stable, okay, because only the last few digits are being changed. It's not like changing from 245 to 252 or something like that. It's just, the number of just a few kilobytes, 10 kilobytes, 15 kilobytes is changing every 1 second. So it's in kind of a stable state right now. Okay, so that's the free command, and also the watch command, which is an important command to know, because the watch command will let you look at some command that is just like a snapshot and make it a sort of a dynamic command. Okay, so that's a good trick to have in your bag as a system administrator if you want to monitor the changing of some particular aspect of the system. All right, now I want to talk about a few other commands that are kind of like a suite of commands that are going to help us track the performance of our system with regards to memory, I/O usage, CPU usage, and also the network usage. Okay, so the first one I'm going to show you here is the vmstat command. And if you look at an info page for vmstat, there's all sorts of options for it, but this is the basic output, and let me just kind of run through and explain what some of this stuff is. Okay, so there's basically like 4 or 5 categories here: the processes, the memory, the swap, the I/O, the system, and the CPU. And now what I want to do is just explain what all these various subheadings are for each one of these. Okay, so the processes is the number of processes on the system that are waiting to run. That's what's under the R column. The B column is the number that are sleeping, and the W column is the number that are swapped out. Okay, under memory here are these 4 particular headings. Okay, SWPD is the number, or is the amount of virtual memory used on the system. Okay, free is the amount of free memory or idle memory, and buff and cache are basically memory that's being used for system processes. Buffers are like the buffer memory is stuff that, if you're writing to disk, you don't actually write to the disk, you write to this buffer, then the operating system writes the buffer out to disk. So that buffer memory is stuff that's being used by the system to accomplish those sorts of tasks. Okay, swap here is the amount that's been swapped in and swapped out, and you can see that's not being used because our system isn't really being loaded up. And I/O has to do with the number of blocks in and blocks out. So this is the number of blocks that have been sent to an I/O device, and this is not the number of blocks that have been received from an I/O device. System here, IN stands for the number of interrupts per second, and CS is the number of context switches per second. So what's an interrupt? What's a context switch? Well, the short version is that an interrupt is generated by a program when it needs some resource in the system. Okay, so a program's running and it needs to write to disk. Well, it can't just control the disk and write to the disk. Everything would fall apart in your system, right? The operating system has to intervene here and actually take care of that write to the disk for the particular program, and the way that the program gets the operating system's attention is by causing an interrupt. Okay, so it's saying here there's 84 interrupts per second. The number of context switches per second is the number of times per second that the CPU sort of changes what program it's running. Okay, so it'll run a program for like a split second, and then context switch, run some other program for a split second, that sort of thing. So a little while ago I was telling you that the CPU is being shared amongst all these processes, and the CPU is changing what it's working on hundreds and hundreds of times per second. Well, here it's telling you 253 times per second is how often it changes. Okay, and this number, when you start thinking about computers in these terms, it just makes you feel completely inadequate when you can't like walk and chew gum at the same time, right? That the processor is operating on 253 different things every second, and it's changing what it's working on, and it's being very efficient all at the same time, right? So that's just the amazingness of computers or something. Okay, so under CPU headings here, we have the percentage of user time time that, or the percentage of time that the CPU is working on user processes, the percentage of time the CPU is working on system processes, and the percentage that the CPU is actually idle. Okay, so that's vmstat. Now let's go ahead and look at one of these other commands called iostat. Now let's look at the iostat command, and this command gives a summary of I/O statistics, okay? And for CPU time, it gives the percentage of time that's spent, again, doing user processes, system processes, and idle. It also has a nice percentage here, and this has to do with the percentage of time the CPU is spending while running processes that have had their priorities changed manually. So there's a command in Linux called nice and renice, and they allow the root user to change the priority of some process. And if the root user increases that priority a certain amount, then then it will show up in this statistic. But the root user really shouldn't be changing the priorities of processes unless there's some real reason to do it. Let the system take care of the various processes on the system. There are reasons to make the priority of a process very low, so it's not executed very often. Maybe it's a very intensive process and you want to wait till everyone else is off the system until you run it, but there isn't really a lot of reasons to increase the priority of some process, and if you do increase it, then it will show up in this percentage under this iostat. Okay. Then what happens is for the various devices on the system, the rates are given as follows. This is the number of transfers per second. This is the number of blocks read and blocks written per second. And this is just the total number of blocks read and blocks written to this device. Okay. Now this device is my first SCSI disk, like dev/dev/SDA. Okay. This one has to do with like my CD or something like that. Okay. So this is kind of cryptic, I know, but what you can do is if you want more statistics on a particular device, what you can do is you can say iostat minus X and then say something like /dev/SDA, or you could even give a particular partition here to get information. Now I'll hit enter here, but the statistics are actually longer than the page, and the kinds of things that are on here are pretty detailed, and I don't want to get into all of those, but it has to do with the same kinds of stuff that's up here in terms of the reads and writes per second and things like that. But like I said, it's very detailed, and I don't want to get into all of that right now. But the iostat is a command where you can learn about that. Go check out the man page to learn what all the various output fields are in this command. All right, well now let's look at the netstat command, which has to do with network statistics, and I'm going to give the -i option to just give a summary information here. Okay, if you don't give the -i option, you'll get pages and pages of stuff, very detailed information about all the various ports and things on your computer. What we're going to do is just do the -i option and get a summary report here. Okay, so we've got the interface here is ETH0. Let's just talk about that particular line. Then under MTU here, that has to do with the maximum transmission unit, or the size of the packet. Okay, so this is, and then we've got all of these here. So these are all the RXOK, error, drop, and over. These are all have to do with received packets. Okay, so this is the number of packets we received successfully. This is the number that had an error associated with them, that had errors on incoming packets. This is the number of incoming packets that were dropped. And this is the number of incoming packets that overran the buffer. So when the packets are coming into your system over the network, they're not going like directly into some spot in memory. They're going into this special buffer, and then the processor reads them out of the buffer. And ideally, the processor reads them out of the buffer faster than they come in. But if for some reason the processor is preoccupied and the packets are coming in and they're being put in the buffer and the buffer fills up, then you'll start getting overflowing packets, and that's where this RX over number will come in. Okay? Now these here, the TXOK, TX error, are for transmitting or outgoing packets. So this is the number we transmitted successfully. This is the number of errors on outbound packets. This is the number of outbound packets that were dropped, and this is the number of outbound packets that overflowed the buffer. So you can see there's kind of a skewing here. Again, just the text here of the way the text lines up. But so all of these zeros relate to these three categories here. Okay, so what you can do by looking at the netstat command, if you see numbers here other than zeros, then you're starting to have some sort of a problem with your network interface. Either there's some sort of, there's just some issue there, whether the buffers aren't big enough or whether the processor is preoccupied and things start going wrong, whether there's some flaw in a cable that's causing errors to show up on packets, that sort of stuff. And so ideally these numbers would all be zero in the perfect world. If they're not zero, then that's going to clue you in as to where to start looking for problems with your network. Okay, now the last one I want to show you here of these 4 commands that I was talking about is the MPStat command, or microprocessor statistics. And this one is pretty much a repeat of stuff that we've seen in other commands that I've just shown you, but it isolates out the ones that are specific to the actual processor on the system. We know what all of these are: the percentage of time the processor spends on user processes, system processes, idle, and so on. This is the number of interrupts that the processor is seeing per second. Okay, and so this just isolates out the particular statistics related to the processor. Now the last thing I want to talk about in this nugget before we wrap up is the SysStat suite of resource monitoring tools. So you can see here the address at redhat.com. It's in the manuals for Red Hat 8. And basically the SysStat suite of resource monitoring tools lets you do the same kinds of things that we've talked about already. And you can see it mentions IOStat and MPStat and so on. Okay? But what it is really doing is it allows you to collect system resource utilization data, create daily reports of that data, and then also allow the graphical viewing of that data. Okay, and it's got some scripts and some other tools here that we'll just talk about briefly to give you an idea of what you have to do to get this to work. So to get the SysStat suite of tools on your system, there's an RPM file. It's called SYS-STAT followed by some version number .rpm. You can download and install that. It's not a very big RPM file or anything. And basically what you're doing is, let me just go through what all the different parts are. SADC is known as the System Activity Data Collector. It collects resource utilization information and writes it to files in var log SA. Those files are named SADD, where DD is the date of the month. So if it's the 3rd of the month, it would be SA03, for instance. Okay, so then the logs sort of just recycle naturally. All right, so you only have a maximum of like 31 logs in this particular for this particular program. Okay, then SA1 is a script that runs SADC to perform the actual data collection. So SA1 is this script, and you're going to have that run by cron at regular intervals throughout the day. Okay, and we learned about cron back in the introductory videos. Cron is the tool that you use to make scripts run at regular intervals, either throughout the day or the month or the week or however you set it up. SAR produces reports on those files created by SADC, and those reports are written to var log SA named SARDD instead of SADD. Again, DD is the current day of the month. Okay, SA2 is a script that uses SAR to write a daily system resource utilization report. ISAG is allows you to graphically display the information collected by SADC. And finally here, SA summarizes system accounting information. So you can set up these scripts to run at various intervals. They tell you when they should run. SA2 should run once at the end of each day. The other one should run at regular intervals throughout the day. And then you'll have all of this data on hand. What this SysStat suite does for us is it allows us to collect information, and store it in log files, and then when things happen that are odd, then various spikes will show up on these graphical displays and so on. That's the problem with all these snapshot tools that I was showing you. It shows you a valid snapshot of what the system is like right now in terms of performance, but unless you have something to compare that to, it's meaningless, right? It just doesn't tell you anything. And so you need something to compare it to, and that's what these tools do for you, in the sense that they're gathering information constantly at regular intervals throughout the day, at every day of the week. And then when you look at things, you'll be able to draw a more educated guess as to what's going on in your system. If I tell you that the load is 3.1 or something, that doesn't help you unless you know what the load has been for days and days previous to this. If I tell you this is the number of interrupts that are happening in the processor, or this is the number of packets that are being dropped over the network, none of these things really mean anything when they're out of context. Okay, and that's what the SysStat suite is trying to help you do. Just collect data at regular intervals and keep track of all this stuff. Okay, well, it's time to wrap up our nugget on performance monitoring, and let's wrap it up by going back over the various things that we wanted to be able to keep track of, and then talk about the utilities that we learned that can keep track of these things. Okay, so overall performance and active processes, we can keep track of those with the top command. The uptime command gave us those load averages for overall system performance. There was also the GNOME system monitor. I'll just abbreviate it like that. The way that you execute that is you type GNOME-system-monitor, and that was a graphical utility that let us see the active processes and the performance of the system. Memory usage, we could use the vmstat command. For disk usage and performance, we use the iostat command for performance of the disk subsystem. For disk usage, we would use commands like we learned back in the introductory Linux series. df and du were commands that would keep track of the disk usage of the system. CPU utilization, we did that with the MPStat, which stands for microprocessor statistics. For network usage, we would use the netstat command. Okay, and then don't forget about that suite of utilities that I mentioned at the end, which is SysStat. And anybody that's serious about keeping their system running at the highest performance possible and keeping track of how this system is running under various stresses and strains of day-to-day activities should be running SysStat and follow the advice in the manuals to run the cron jobs at the right times, and then you will have the ability to see the performance of your system in graphical output and have reports done on a daily basis. Well, I hope you found this nugget informative, and thanks for watching.